Morning to one and all. Today we will talk about the concept of data warehousing and analytical processing. Data warehousing means it is a subject-oriented, integrated, time-variant, and non-volatile collection of data for decision-making process. Data warehouse is nothing but the process of constructing and using of data warehouse is called data warehousing. And the characteristics of data warehouse are first one is subject oriented, means here it can be used to analyze on a particular subject. Example, e-commerce. Here we have in the data warehouse subject sales and customer and operational application, order processing and customer billing. Integrated means data warehouse is a careful of retrieving information from different sources like flat plus relational databases in order to make efficient strategic decisions due to different data sources. Here, retrieving data from different sources, data should not be in consistent manner, it should be in consistent manner, not in consistent manner. So, to overcome this problem, we are using different techniques like data cleaning and data integration on need to be applied. Therefore, it is necessary to perform data transformation and consideration before transferring the data from operation system into data warehouse. Here I am taking the subject account and maintaining three accounts, savings account, checking and loan account. These three accounts should be integrated. Time variant means data warehouse has to contain historical data, not just current value. The past 5 to 10 years, every data structure in a data warehouse contains time variant. Futures means it can allow the user to analyze past data, maintain information to the present, predict the future values. And then non-maintained means here data is not updated or deleted from the data warehouse in real time. There are only two operations can be performed in data warehouse. One is data loading and data accessing. Data loading means here just it can load the data. Data accessing means here the user can only read the data. The user cannot add, delete, and modify it in the data warehouse. Because of the above features, data warehouse is considered as a consistent storage area that provides support for decision making and analytical reporting. OLTP. OLTP stands for Online Transactional Processing. It is mainly focused on recording current update, insert and delete while transaction. OLTP requires queries are simple and short. It takes less time and less space. Get data frequently updated. If the transaction is failed in the middle, it may affect the data integrity. So it must take care of data integrity. In OLTP, database has normalized tables. The best examples for OLTP is an ATM, which is used for short transaction. We modify the status of your account also. OLTP system becomes a source of data for OLAP. The output of the OLTP becomes the input to the OLAP. OLAP stands for Online Analytical Processing System. Database stores historical data that has been inputted by OLTP. Here in OLAP, the takes long transaction, require more space and more processing time. Here the tables are not normalized here. It allows the user to use different summarize of multidimensional data, extract information from large database, analyze it for decision making, execute complex queries to execute multidimensional data. In OLTP, even if the transaction fails in middle, it will not harm the data integrity. If the user uses OLAP system to provide data for large database to analyze, simply the user can execute the query again and extract the data for analysis. The best examples for OLAP is financial report, budgeting, marketing management, and sales report. Next, what is the differences between OLAP and OLTP? It involves historical processing of information. In OLTP, it involves day-to-day processing. OLAP systems are used by knowledge workers such as executors, managers, and analysts. So, OLTP systems are used by clerks, DBA, or database professionals. OLAP is a market-oriented used for data analysis, and OLTP is a user-oriented user for query processing. It is responsible for performing long-term operations. It is responsible for performing day-to-day operations. This OLAP is based on star schema, snowflake, and flat consultation schema. And OLTP is based on entity model. OLAP is historical and highly summarized, but OLTP is up to date, elaborate, and is highly detailed. OLAP is subject oriented, OLTP is application oriented. It provides read only pattern, it provides both read and write pattern. In OLAP, concentrated on data which is output from a system, but in OLTP, it concentrated on data which is input to the system. OLAP requires less number of users, but in OLTP requires more number of users. It measures the query efficiency in OLAP, but with OLTP it measures the transaction efficiency. OLAP takes large number of records can be accessed. Here in OLTP, less number of records can be accessed. Database size in OLAP is 100 GB to 100 TB, but in OLTP the database size is 100 MB to 100 GB. In OLAP is highly flexible, but OLTP is highly performance. It is highly performance provide. In OLAP, profit process complex code, but in OLTP, profit process short and simple transactions. While we need a separate database, an operational database is constructed for well-known tasks such as searching particular record, hashing using primary keys, and indexing. Database queries are often complex and involve calculation of large groups of data at summarized levels. Data warehouse is kept separate from operational database due to the following reasons. The first reason is it requires a special data organization access and implementation methods based on the multidimensional use. Browsing OLAP queries in operational database will significantly reduce the performance of operational transactions. Concurrency control and recovery mechanisms are required for operational databases to ensure robustness and consistency of the database, but it is not complete with OLAP. Operational database query allow you to read and modify operations, allow only read only in OLAP. Maintenance means in operational database it can maintain current data, but in data warehouse it can maintain historical data. Consolidation means here data warehouse requires consolidation such as aggregation and summarization of data from heterogeneous sources. It results in high quality, clean and integrated data. Operational databases contains not only detailed raw data such as transaction which need to be consolidated before analysis. The two systems provide different functionalities and require different kind of data. Measures their categories and computation. A database is a numeric function that can be evaluated at each point in the database space. Based on the kind of integration function used, the measures can be divided in three ways. First one is distributed algebraic function holistic. Distributed means if the result derived by applying the function to the n aggregate values is the same as the derived by applying the function to the entire data set. An aggregate function is distributed, it can be calculated in a distributed manner as follows. The best example for distributed is count. The count can be computed for a data cube by first partitioning the cube into a set of subcubes and compute the count for each subcube and then adding the count obtained for each subcube. Here count is a distributive aggregate function for the same reason sum, min, max or distributive aggregate functions. Algebraic means is a measure that can be computed by applying an algebraic function to one or more distributive manners. For example, average and mean can be computed by sum and count. So both sum and count are distributive aggregative functions. Min and max are and standard deviations are examples for aggregative functions. So algebraic functions. Holistic means is a measure that must be computed on the entire data set. It cannot be computed by partitioning the given data into subsets and managing the values obtained by the measure obtained for the measure in each subset. For example, need, modian, and rank is an example for holistic. But holistic measures are more expensive to calculate than distributive measures. Concept hierarchies are defined as a hierarchical mapping of low-level attributes into high-level attributes. There are four major types of concept hierarchies. One is schema hierarchies. Schema hierarchies specifies as partial or total orders of attributes such as schema level, specified by the user to indicate the semantic relation between attributes. Here we are taking the example of a student engineering course. The possible attributes can be course, department, institution, and affiliated university. Here the schema hierarchy clearly specifies the relation between attributes. These specifications is more meaningful than a list of values for the attribute. Subgroup hierarchies means categorize the dimension or attribute values into groups by specifying a range for each group. The attribute percentage can be specified in terms of range of values to organize into groups. Here 40 to 59, 59 is come under second class, and 60 to 74 comes under less than 60 to 74 less than first class, come to first class, and 75 to 90 comes under distinction. Derived hierarchies means it specifies hierarchy information based on user operation. The information is obtained by decoding operation by a set of URLs listed by the user. URL specifies the hierarchy of a website on a website. Rule-based hierarchies means a set of rules used to specify a concept hierarchy. Students are categorized based on the total marks. They categorize as first, second, and distinct. Students with total marks below 400 are put into second class. Students with total marks between 500 to 650 are put into first class. Students with total marks greater than 700 are categorized as distinct. So, for rule-based hierarchies, we can write the rules like this. Distant of x less equal to marks of x greater than 700. And first class of x equal to marks of x less than 500 and marks of x less than 850. Second class of x equal to marks of x less than 400. StarNet query model for query in multidimensional database. The querying of multidimensional databases can be based on a StarNet model. It consists of a array line starting from a central point where each line represents a concept hierarchy for a dimension. Each abstraction level in the hierarchy is called a footprint. The StarNet consists of four radical lines representing concept hierarchies for the dimensions, location, customer, item, and time. Each line consists of footprints representing abstraction level of dimensions. For example, the timeline has four footprints: day, month, quarter, and year. A concept hierarchy may involve a single attribute date for the time hierarchy. Several attributes, the concept hierarchy for location involve the attributes state, city, provenance, state, and country. Thank you, Manima.